Okay, YouTube, in this video we're just going to really work on writing these expanded logarithmic expressions as single logarithms using our properties of logarithms. So I just wanted to run through some extra examples of condensing. And so remember, with condensing, what we're going to do first is we're going to put back powers first if we can. Two, we will put back products if we see any products. And what we're looking for when condensing is we're looking for sums. Okay, those will go back together as products. And then our third property, which was our quotient rule. This is our quotient rule, and a quotient will result if we have any differences in our expanded logarithmic expression here. So what we're going to look for first are powers. So when we look at letter A here, we have this 2 ln x plus 1/3 ln x plus 5. What I notice is that these powers are out front, and I say powers now when really I should wait a second. When we put those back, this is letter A here. I suppose that 2 ln x, remember that's the same thing as ln of x squared, and what we've done is we've really taken that power that we pulled out front and put it back. Same thing here, we're going to put this power back on, so we get ln, and in parentheses here, this is x plus 5, and this is all being raised to the 1/3 power. So now, in terms of putting things back, I look for products next, and of course, that's the sum right there that's going to give away that we have a product, but we can rewrite this as the natural log of all of this together, where we have our first factor is x squared, and our second factor here is this x plus 5 to the 1/3. So my last suggestion is, if you're dealing with logarithms, when you deal with radicals, it's often good to deal with rational exponents. Okay, but when you're done and you've condensed this, it's not a bad idea to go ahead and rewrite this as a radical expression again, just to get the hang of it. But this would be our final condensed expression right here. And a good thing to do is just to take it back apart again and make sure you get what you started with. So let's take a look at letter B here. Okay, so letter B. Again, I notice a power out in front, or at least a factor out in front. We could call this a power. So we have log of x minus 3. It must be a common log. And we say, we'll put that power back, minus the log of x. Now, because these two logs have a base of 10, and I am subtracting them, then we could really interpret this as there's a difference here. There must have been a quotient in our single logarithm. So we say the log, what we're going to do here is this. We're going to rewrite this as a quotient. Now, the important thing is that the top part here comes from our first log in this difference. So we would get x minus 3 squared, and on the bottom part we would just put this x, and this would be our condensed expression for part B. Now letter C, C is a good one, and the reason why is because we have a double difference. So we'll deal with that when we get to it, but let's go ahead and start with our powers. Again, I notice these numbers out in front, we need to put them back. So there are two ways to go about this. Certainly one of them is to rewrite this as adding the opposite of each of these terms. And so certainly we could do that. What I'm going to do is I'm going to leave it as a difference for now. And so I'm going to put these powers back on, and we'd say that it would look like this now. We have log base b of, and I suppose this would be x to the 1/4. So we have x to the 1/4 minus, now we'll put our log back here, minus log base b of 5 to the 2nd. Minus log base b of y to the 10th. So all of our powers being back on here now, what we're going to do is we're going to work with just two of these at a time. And I notice because this is a difference here, just like our last one, we have a quotient. So we have log base b of this quotient right here. And in this quotient, I suppose we'd have the 4th root of x on top, and we would have 25 on the bottom. And this is still subtracting off log base b of y to the 10th. So what we're going to do is we're just going to do this again. And we're going to say that in this instance, we have log base b of this quotient here, where on the top we have the 4th root of x all over 25, and this is all over y to the 10th. Now, one thing I want to point out is this y to the 10th, you could look at this as being over a 1 like this. And so what we end up with is really just multiplying the reciprocal. We get this. If we were to take the 4th root of x over 25, and divide by y to the 10th over 1, that's the same thing as the 4th root of x over 25 multiplied by the reciprocal. We get 1 over 25, sorry, 1 over y to the 10th. So multiplying these together, on top we get the 4th root of x, and on bottom we get 25y to the 10th. We could look at this then as, here we go, log base b, all of this, just to get this here, we get the 4th root of x all over 25y to the 10th. And here is our condensed expression. Cheers.